Sustainability is something where if you're in the lab and you're designing new processes, you're designing a new lab building even, you think about how can we set up this whole operation to be lower impact and to be more sustainable while still achieving its aim.
If you work in the lab, there are everyday items that create huge carbon emissions, whether it's ultra-low temperature freezers or consumables. All of it adds up to around 20 tons of carbon per laboratory every year.
Built to make scientific research possible, these tools leave a footprint we're only just beginning to fully comprehend. The good news? Scientists have the power to shrink it.
You've got the most educated, well-informed people in the globe, you could argue. If science can't lead the way in sustainability, then who can?
In this episode, we break down the major sources of a lab's carbon footprint. We'll explore how to spot greenwashed products, share inspiring sustainability success stories, and show practical ways you can make changes in your own lab.
I'm Kai Nussbaumer.
And I'm Micah Schweitzer. This is Balancing the Future from METTLER Toledo.
On this show, we delve into the world of science and technology and explore its transformative impact on our lives.
We often kind of divide like the lab's impact into three areas to start with, kind of energy, water, and waste. I think the really good thing is like, we can all picture that, we can all identify with that, we can all imagine that in our household and then multiply it up in the lab.
That's Raj Patey. He's Business Development Director at My Green Lab.
This organization is on a mission to turn labs worldwide into environmental leaders.
They do this through certification programs, product labeling, and challenges that promote sustainable practices.
We'll talk a little more about My Green Lab later.
And I think within that as well, you could also split into kind of lab process, and then you've got all the things that come into it, which also align with the way that carbon impact is reported as well, in terms of like scope 1 and 2, which relate to process, and scope 3, which often relates to supply chain as well. But yeah, so you've got bits of equipment that use crazy amounts of energy, for example, things like ultra low temperature freezers and fume hoods and things like that. You've got processes which utilize large amounts of water, solvents and other chemicals. And you've also got processes which, in order to get them done and as their output alongside the science, use and then output as waste mass amounts of plastic. I was on a lab tour recently at a large pharma company, and you will have in each lab racks full of plastic tubes, plastic pipette tips and things like that. And that might only be 1 or 2 days worth that you're seeing there in the room now. I once spoke to a lab plastics manufacturer, and they said, oh, we're pretty small in the global industry. We only made 4.5 billion plastic pipette tips last year or something.
Wow.
And if you think that those are literally single use by definition bits of plastic, they get used for a very short amount of time and then disposed of. And then I think the other thing is like, why is it so intense, is most of these operations are going on at minimum 9 to 5, and in quite a lot of scenarios 24/7 as well. So you've got all this high intensity application, activity, etc., that's quite often running all of the time as well.
And so if you're looking at these three different areas, energy, water, and waste, do you have, so to speak, low-hanging fruit to reduce environmental impact in some of those areas? Or conversely, are there areas that are really kind of difficult to address?
It does vary, I think from lab to lab. I mean, on the energy side, for example, we run a thing called the International Freezer Challenge, which is kind of very well known in the lab environment now. And that attacks the low-hanging fruit of cold storage in a laboratory environment. So if you ever go into university or farm schools, some of these places, you can literally walk down corridors or sides of the lab or whatever, where there's rows of these ULT freezers. And it's not down to kind of -10 to -20 like you might have at home. It's down to -80. And so to keep things at -80 uses crazy amount of energy. In fact, kind of a very broad stat is that one of those large ULTs is in order of magnitude energy equivalent to a household. Yeah, there's houses in different parts of the world, different sizes. It's big whichever way you look at it. So those and things like fume hoods as well, and maybe centrifuges are also big hogs of energy that with small tweaks, like for example, as the International Freezer Challenge promotes, changing them from -80 to -70 can reduce the energy consumption by 20 to 25%. but actually be perfectly safe with a large amount of samples. So, and then you've got things like, waste. I mean, I always, it's a little bit simplistic, but if a lot of your waste is plastic, for example, can you use less plastic? If a lot of that plastic is, for example, disposable gloves, are there different approaches you can take? Can your protocols be changed and things like that?
And whose responsibility is it to think about these things? I mean, who's going to change the protocol around disposable glove usage, or who's going to say, yes, the samples are safe at -70?
I guess on a very simplistic level, you could say the lab manager. Is the lab manager enabled and empowered to do that, though, is a separate question. They and their team might have a lot of great ideas. They might work with us on things like our Green Lab certification program to increase the pool of ideas, to drive that harder. But are they enabled, empowered, funded, etc., to do that? That's where the top down comes, really.
We are seeing more initiatives that empower faculties and individuals to make real change, and the results are already showing.
Some universities, like King's College London, have made major strides, becoming one of the first to achieve a 100% sustainability accreditation rating for their labs.
Others, like the University of Bath, have seen annual savings of £11,000, nearly $15,000, just by making a fractional increase in their freezer temperatures.
Together, these big and small changes show that whether it's a major institutional shift or something smaller scale, every effort counts towards building a more sustainable lab culture. So, can you give us a quick elevator pitch on what My Green Lab does and what exactly it is?
Sure, I'll do my best. Whether we talk about pharmaceutical labs, university labs, hospital labs, all the other areas where there are labs, everyone these days has goals to reduce their environmental impact. And you might go, well, why this lab focus? Why are these goals there? Well, labs consume massive amounts of water, generate massive amounts of plastic, chemical and other waste, and consume massive amounts of energy. And just to throw kind of one stat at that, because people always love stats, the University of Bristol here in the UK, actually, which is where I attended, they calculated a couple of years ago that in their campus, labs account for about 6% of the square meterage of the campus, but they actually account for over 45% of the energy consumption. So I think in one stat there, you really drive home the high impact of labs. And so at My Green Lab, everything starts with awareness. So we offer things like free to access training courses like our My Green Lab Ambassador program and also our Accredited Professional program. And then as you progress through that journey, we have our gold standard My Green Lab certification program, which is really about driving more sustainable lab operations. It's actually utilized by 42 of the largest pharma and biotech companies globally, alongside many universities. Hospitals are growing and starting using it, and areas such as food and beverage. And then when it comes to the laboratory supply chain side of things, to really enable kind of higher standards and transparency and communications in the lab supply chain, we offer the only third-party verified eco label, which has been designed in collaboration with lab suppliers, manufacturers, and lab purchasers as well. It's aligned with the latest EU legislation on greenwashing, and it's approved by the US EPA. And really, to finish off, our mission statement is to build a global culture of sustainability and science. So that collaborative approach across the industry is all about achieving that.
And so you're talking about the ACT eco label here.
I am, yes, yeah.
And what does ACT or ACT stand for in this context?
A is for accountability. So if you're a manufacturer such as METTLER TOLEDO, it's about you as a manufacturer being accountable for the environmental impacts of the products you put out into the market. And really importantly, I think, for working to reduce that over time. C is about consistency. Consistency you can take in several ways. It's about the fact that that ACT label is measured, audited, assessed, etc., in the same way for every manufacturer, every lab product, be it a consumable, a chemical, or a piece of equipment. And T is transparency, which I think remains and has always been, I think, the most important letter of the three. It's about manufacturers being open and honest in a third-party verified, standardized, data-driven way about disclosing where they are today about the environmental impact of their product from manufacturing through to end of life. But really importantly, therefore, that they're on a journey of improvement, which is where their customers want them to be.
And can you describe for us how exactly this label looks like?
Sure, yeah. So a really good analogy, which we use a lot, we're all familiar, I think, wherever we are in the world, largely with nutrition labels on food in the supermarket. But we're not talking carbohydrates, fat, protein, all that type of thing. In this case, we're talking laboratory product sustainability. So things like what goes on at the factory, what are the energy inputs into the factory, where are the materials coming from, for example. In the usage phase of the thing, how much energy or water does it use if it's a bit of equipment? How long does it last? And that type of thing. And then at the end of life of that product, what's going to happen to it? Does it end up in landfill? Can the materials be recycled? So picture those as different lines on your nutrition label, as it were, but on your Axe Eco label, and each one of those then being assessed, given a score, just like a lot of nutrition labels in some countries, color coded. Green scores are better, red scores are areas of improvement, and that type of thing. So that comes together to give you a kind of an overall kind of health or rating, if you like, but also those individual data points.
So, how are these metrics measured?
In the background, there is what we call a standardized verification process. For each of the criteria you see on that label, there are defined data points, asks, and it really starts with, in each of those, manufacturer first of all identifies the claims they're looking to make. For example, at our factory, we are looking to claim that we use 50% sustainably sourced energy from wind, from hydroelectric, from some other source. And that carries on through. We believe that we have 45% recycled aluminium in the case of this. We offer an end-of-life recycling scheme. And then the auditors will go through that and they'll say, right, well, you need to verify these claims. Okay, the way you verify your claims on the energy, for example, is we need to see this documentation, that before and after of implementation information. You offer a recycling scheme. You see the documentation of how you show that to your customers, how you actually implement it. So for each claim, just like in any audit process, you need to say what you're doing and verify how you're doing it. And in the background, by the way, that aligns as well with a lot of external global standards as well.
Yeah. So are there any products that just don't get certified or are really hard to certify?
From an Axe Eco label point of view, pretty much we've looked to standardize the approach across all chemicals, reagents, antibodies, consumables, small and large, equipment, small and large. If there's somewhere where we have a kind of a boundary right now, although we do have work in hand to extend that boundary at the moment, I would say it's kind of where something is what I would refer to as kind of building level connected. So when you get into very big infrastructure, so for example, HVAC and air conditioning is an inherent part of every lab from a safety point of view. We don't Axe label that. That's kind of building level stuff. And actually, there's other agencies that work very well in that area. But things that connect to that, things like ducted fume hoods, for example, calculating the energy usage in those is quite complex. We actually have projects in hand to do that at the moment. But right now, our boundary is if the scientists can touch it, move it, directly control it, that's kind of in some ways where you define our boundary, I'd say.
And what is the cumulative effect of less energy-intensive equipment, for example, like a lab balance?
That's an interesting question, actually, because, you'd think of a lab balance of, well, that's a tiny, small thing. It has one of those tiny little power blocks that goes into the wall. The energy consumption of each one is pretty small. But on the other hand, you can go into some labs and there'll be a lot of them. So, that can add up. But actually, I think the other thing as well is when we look at any type of product, including a lab balance, and we look at its environmental impact, its impact on the carbon impact of that lab operation, this is kind of a really important point about what we're trying to do with Axe and about what we spoke about a bit earlier when we kind of described the label. If you think of like the life cycle of that balance, energy is a bit of it somewhere in the middle, right? It's what I'd refer to as the usage phase. However, what happens before that? Well, it's in a factory which uses energy to make it. Those materials have to come from somewhere. What's the quantity of those materials? Can they be reduced? Where are they being sourced from? It has to be packaged, etc. It has to be shipped to the customer. And then when it's broken or no longer utilized by the customer, that balance and that packaging has to go somewhere.
In some sense, you could argue that a piece of equipment that uses a bit more energy but has a longer life cycle might actually have lower embodied energy in total than something that uses very little energy but requires more energy to create and dispose of or has a shorter life cycle.
Yeah, let's split that up a little bit. So lifetime, I guess what you meant by life, how long something lasts is also definitely a consideration for the Act's eco label. And yes, to state the hopefully blindingly obvious, we want to encourage manufacturers to make things that don't die after 1 year, but last many years and continue to give a quality offering for many years. And included in that is also variables like ensuring that spare parts are available for a long time. For example, if it's something that needs servicing or repair periodically, that is available for a long period of time. And even after maybe when a product goes out of end of line of manufacturing, that it's still supported appropriately. And I guess, to answer your question, something could theoretically have a slightly higher energy consumption, but if due to its increased longevity, the time before it needed replacing was a lot longer, and therefore there was less, you didn't need to make another one, those will balance out. And that really identifies why we need to look at products in this kind of holistic fashion. Let's not ever just zoom in on one stat of a product, because that can actually be quite misleading. And that's kind of quite often where things like greenwashing come from, actually. We found one positive thing to say about this product, and we're going to carefully not mention any of the rest of them. So.
Detecting greenwashing isn't always easy. A product might claim it's recyclable, but if your local facility won't accept contaminated waste, that label doesn't really mean anything.
So how do we avoid buying greenwash products? According to My Green Lab, we should watch out for vague terms like eco-friendly or green and look for verified certifications instead.
My Green Lab's Act Eco label is a good example, but if it's not available, the more data a product provides about its origins and recyclability, the better.
To make smarter choices, get to know what your local recycling facilities can handle, and stay informed about sustainable practices while pushing for transparency in your lab.
We already told you about a few sustainability success stories, but what about those organizations that My Green Lab has worked with?
So GSK, a global pharma, they did a pilot initially in 3 labs. And in that pilot exercise, they saved around 426,000 kilowatt hours of energy, which is equivalent to 150 tons of CO2 equivalent. They saved 137 million litres of water, and they saved approximately $226,000 in cost savings in a year. And this was around 14x kind of return on investment on their costs, in addition to all that CO2 and money saved. That was a pilot. And the great news is that they're now rolling out that strategy in this program globally across their organization. So lots of numbers there, but either way, through some process change without compromising quality, safety, or anything else, they have made, and that story hangs true in many of our partner organizations.
And I think part of what I'm also hearing in that story is that sustainability is actually profitable in this sense. I mean, it leads to tangible cost savings for a company.
I'm quite idealistic myself, obviously, but we have to align this with business operations. And in fact, sustainability, we could argue, is only really part of your culture when it's embedded in your. So we see that whether it's labs doing My Green Lab certification, we see these monetary return on investments alongside the carbon savings in terms of X in and multiples of X out in terms of savings in energy, water. And it's not all just so obvious, by the way. I mean, energy is very easy to understand. I turn my lights on less, I save energy, I have a lower bill, right? If you're in a lab, you have to pay a lot of money to dispose of your toxic waste, for example. So if you can change your operations to reduce your waste output, that's another cost saving. And if you're a lab supplier, we increasingly see that consumers are so focused in this area that demonstrating that transparency, showing that you're on that journey of improvement through ACT with your customers, is actually enabling more sales, opening more doors, and therefore speaking to that word profitability that you mentioned.
You say consumers are focused on this area. Can you give a sense overall of how focused the laboratory world is on reducing environmental footprint?
So I and my colleagues go to a number of scientific conferences, trade shows, etc. each year. I've been doing this with My Green Lab for a number of years now, and I feel like there are 2 common themes at pretty much all of these events. Now, the first one, outside of the context of labs, is probably people won't be surprised at. It's kind of the transition to cloud computing, data, automation, AI. That's a hot topic in science, just like it is everywhere. Do you know what the other one is at all of them? It's sustainability. There's sustainability tracks in all the talks. All the manufacturers are trying to understand how they can present themselves as more sustainable to their customers and that type of thing. And then I think the other thing, just to add a kind of second kind of validation point on that as well, is in Europe especially, a lot of business is done through tenders and framework agreements. And the bit of info that myself and one of my colleagues who looks into this a bit has started to pick up quite a lot just in the last year is in all these agreements, everyone looks at price, obviously. Price is a given. You've got to get your price about right if you want to sell something to someone. There's all these other criteria. What's rising to the top regularly as after price? The next most important criteria, sustainability. And when it's being put into those high-level agreements, points are being awarded, businesses being won off the basis of it, etc. So I think that's a really good indicator as well.
You mentioned that sustainability is a bit of a buzzword at the conferences that you go to, but what are the most common misconceptions about lab sustainability, and how do you address them?
So I think you could harness it, first of all, in just a few words: cost, safety, process. People go, oh, I want to be greener, I want to be more sustainable, but it costs me more, right? Well, we've already talked quite a lot about how that is a myth. And also, I think what's fair to say is that statement had a bit more value a number of years ago, but the market is shifting so fast to, if you want to be part of this market, you need to be working to be more sustainable with your customers, that the pricing is sorting itself out. The other, I think, misconceptions around, oh, but will it impact my safety in my laboratory? Absolutely not. To be clear, everything that we recommend, guide towards, etc., in things like the My Green Lab certification program, run parallel with and are designed to sit it's hand in hand with quality output, safe outcomes. And you could even make arguments sometimes that a more sustainable lab is even a safer lab, in the sense of, for example, if you switch away from very toxic chemicals to chemicals that are safer to handle, that you can have inherent gains like that and that type of thing. And then I guess processes along the same kind of things. It's funny, scientists, are all about bettering and furthering the world, but scientists are also incredibly conservative. Why do we do a process this way? Why do we use that bit of equipment? Well, we've always done it that way. And I learned that from, my prof at university or my PI at university when I was, so I've just carried on doing the same thing or whatever. So that's the other one that needs to be overcome as well.
But many lab managers are stepping up their sustainability game.
An estimated 82% of labs have already implemented measures like cutting carbon emissions, reducing energy use, and improving waste management.
Efficiency and environmental safety are the biggest drivers behind these changes. And labs in the UK, US, and China are leading the charge with widespread adoption of sustainability metrics.
Reducing emissions is the most common action, especially in environmental testing and life science research.
There is, of course, much more work to do on this, but so far results are promising, which makes one wonder what else could be possible in the future of this field.
First of all, labs continue to innovate in terms of what they deliver to society, and they continue to do that in a high quality way. And if you're a commercial organization that's profitable and all those types of things as well. As we talked about, they're potentially safer and lowering costs and that type of thing. But really, to speak to our own mission, they work in a way that leaves the planet in a better place for future generations, not a worse place, where they've truly embedded a global culture of sustainability within themselves and in wider science, and science is therefore leading the way. We often say, sometimes, if science can't lead the way in sustainability, then who can? Because you've got the most educated, well-informed people in the globe, you could argue. And I think, just to add one point to that, what do we talk about when we talk about a culture of sustainability? And also, to relate to your question before, actually, how can manufacturers think about this more? Is sustainability is not an add-on. It's not like we made a product, for example. Oh, right, what should we do about sustainability now to market it or whatever? Sustainability is something where, if you're in the lab and you're designing new processes, you're designing a new lab building even, you think about how can we set up this whole operation to be lower impact and to be more sustainable while still achieving its aim. And if you're a lab product, when we sit down with a metaphorical, probably computer screen, but blank sheet of paper to design that next lab product, how can it be designed in such a way that it achieves the aims of the organization wants and the customer wants? But maybe it's lower impact to manufacture. It uses better materials. It lasts a longer time, to speak to one of your questions earlier. It uses less energy if it's using energy. And when it finally reaches end of life, it's easy to dispose of and recycle the materials in an appropriate way and that type of thing. And I think at that point, if everyone's planning their experiments and their products like that, then that's where we hope things to be alongside the broader statements.
Now, can you let listeners know how they can find ACT certified products?
Yeah, if you go to act.mygreenlab.org online, you will find the ACT database there. And you will find, I think it's pushing 1,700, 1,800 products there at the moment from, I think it's around somewhere between 40 and 50 manufacturers. And what's really exciting actually is as we are now in the process of transitioning from ACT 1 to 2, you'll see Act 2 products start to appear there in the coming months as well. And you'll actually start to see, having only launched Act 2 a few months ago now, you'll actually see the number of products there.
So you touched on there being a transition into the new ACT Label 2. Was there a big difference from ACT Label 1, or is it just in the design?
It's really an evolution, a learning of lessons learned over many years. A little bit of background. So Act 2 has been a process we've been going through in the background for over a year. It's kind of built by the industry for the industry. So we have a steering committee in the background of manufacturers, key buyers from pharma, academia and elsewhere, and a range of technical experts. And they really were given a task of, we need to, in 2025 and for the next few years, have rebalanced the needs and the wants of the two stakeholders. They are manufacturers and they are consumers, and they don't always agree, funnily enough, in terms of what they want out of it. In terms of the changes, underlying, it still looks and feels quite similar. It's about communicating the attributes that we talked about in a clear way, but we try to improve that as well. So, for example, in an Act 1 label, you might see product content 7, and you might, oh, what does a 7 mean? In Act 2, it's very clear. It says recycled renewable content in this product is 60%, of which 80% is recyclable. So we've improved some of the language and communication and things like that. We've also adding that weighting around carbon impact that we talked earlier to better align again with what consumers are asking for and to better guide manufacturers to drive future improvements. It's a single globally applicable label like we talked about before, whereas before we had the regional labels. And I think the final thing I'd mention as well is that we've worked hard in the background with some external agencies, including the US EPA, the Environmental Protection Agency, and also agencies in Europe and in Germany to align with the latest European legislation around EU green claims and greenwashing and things like that, to ensure that it's aligned with today's legislation, today's best practice and that type of thing as well.
Can I just key in on the interesting point you made? You said that consumers and manufacturers are not always aligned on what they want or what they need. Can you talk a little bit more about that?
I mean, I guess on one level, and this could sound slightly cynical, but it's the reality sometimes, of course, in a kind of supply purchase environment, consumers want one thing, manufacturers might, oh, that's not possible, I can give you this instead, or I want to give you this because it's easier. Or that. Of course, at the core of our organization, we want to drive improvement. So there are things in Act 2 which are quite a lot more difficult for manufacturers to achieve than in Act 1, for example. That's where the consumer's like, well, we need you to push them harder to keep improving, finding happy mediums in areas like that. And I think a second example, just getting slightly more technical, is one of the new things actually we added to Act 2 that wasn't on Act 1 is there's a section for what we call product carbon reporting. So one of the hot questions that comes from consumers very regularly now is, oh, we want to see what we call an LCA, life cycle analysis for every product. So there's a product carbon number or product carbon footprint number on each product. Now, this is actually a very costly, wieldy exercise for anyone to go through. And in something like the lab product industry, where you have so many millions of items and sizes and variations, there are a lot of challenges around this. So what we tried to do is acknowledge the fact that the consumers are demanding at this level now, but that's not necessarily achievable in 2025. It's a goal for the longer term, but manufacturers need to guide in that direction. So where manufacturers have that data already, there's a place to put it on the label. But really importantly, we made a point of saying, but there's no standardization on how to gather these numbers at the moment. There are some ISO standards and things. They don't even fulfill what we need in terms of standardization. So we put the number on there, but we identify on the label it was done to this standard, or it was self-declared, it was homemade, whatever it was. And that meets the consumer demand for seeing the number, but educates them at the same time that they're not necessarily comparable.
So just to wrap up our conversation here, what advice would you give to researchers who want to increase sustainability in their practices at work?
Before you start changing anything, just educate yourself a little bit. If you want to start somewhere really simple, Google My Green Lab Ambassador. And as I mentioned earlier, that's free to access training. It takes no more than about an hour of your time to take part in. You watch some fun videos. So the first videos, for example, is on energy in the lab. It talks about things like, well, why are we leaving this all night? Just for the convenience of not having to wait for it to warm up in the morning. Start to build your awareness. One of the lessons out of one of the modules in that little training thing actually is then take that to just dedicate 15 minutes of each lab meeting each week to sustainability. So of course, tackle the things that are important in making sure the lab's operating. But one of the things we've observed over the years that in most labs, there are people sitting there literally going, oh, I'd love to do this to make our lab more sustainable. And they just need to be enabled, empowered, given time to voice their passion. And then start thinking about programs like My Green Lab certification that we mentioned, which enable you to actually, in a standardized and third-party verified way, understand where you are today, receive lots of guidance, feedback, and education on how to improve. And also, as part of that, deliver some of those cost savings and carbon savings that we talked about earlier.
We've been speaking to Raj Patey, Business Development Director at My Green Lab. Kai, what were some of your takeaways from the conversation?
Well, the scale of lab emissions is truly shocking. About 20 tons of carbon per lab. That's just a huge figure.
Yeah, I was really struck by the scale as well. On the flip side, I was very glad to hear that things are changing for the better. For instance, the initiatives by GSK saving $226,000 in a year, the University of Bath saving $11,000 through its sustainability initiatives. And I think it's important to note that obviously this results in a reduction in emissions, a reduction in waste, and of course also savings for the organizations and institutions undertaking them, which provides some additional incentive as well.
But of course, greenwashing does remain a challenge. There are really issues with the limited recycling options and a lot of incomplete data surrounding where and how are the best ways to recycle. But fact-based certifications are a strong tool for helping lab managers make better informed decisions. This has been Balancing the Future from METTLER Toledo.
What questions about science and technology would you like answered in a future episode?
Let us know by leaving a review, or if you listen on Spotify, leave us a message in the comments section.
And be sure to subscribe wherever you get your podcasts.